Practice paper year 1, learning outcome 2, question number 8. This one, integration by parts, and you can have a look at the relevant chapter in the textbook as well as the exercises, and again solutions to those exercises will appear. Some have already in the video clip section. So for this particular one I have to use integration by parts to do it because I've got effectively x appearing twice, so it's like the product rule in differentiation. In fact, this integration by parts method comes from the product rule. Once we've done the integration, we then have to put the limits 3 and 2 in to come up with a solution. So there's a few parts to this question. So let's have a look first of all to do the integral. Which bit are we going to let dv, let equal u rather, the bit so that when I differentiate it, the x disappears. So if I let u equal 3x, I'm going to differentiate it to get du, the x will disappear. So let u equal 3x, therefore the differential is just 3, and if I let 3x equal u, then I've got to let e to the 2x equal dv, which means that I've got to integrate that to get v. When I integrate it, the 2 comes out and goes underneath, or we can think of it as a half of e to the 2x. So now we use integration by parts, which tells us the integral of u dv equals uv minus the integral of v du. So plugging these into this formula, effectively, the integral of u dv, which is what we want to find, 3x e to the 2x, between the limits of 2 and 3, equals, all of this got to go in between the limits of 2 and 3, so that'll be uv, and u is 3x, times v, which is a half e to the 2x, minus the integral of v, which is a half e to the 2x, du, which is just 3 with respect to x. So now I've got to do that integral, and this will then all be between 2 and 3. So this equals 3 over 2, tidying up a bit as we go along, to 3 over the 2, e to the 2x, x e to the 2x, minus, I can bring the 3 over 2 outside, integral of e to the 2x with respect to x, between my limits of 2 and 3. So this equals 3 over 2 x e to the 2x minus 3 over 2 times, again the half comes out and goes underneath, e to the 2x, between the limits of 2 and 3. I could take a 3 over 2 outside the integral altogether, so that's x e to the 2x minus a half e to the 2x between 2 and 3. Inside there I can take an e to the 2x outside the integral. Just to make life a little bit easier for myself, I can call that e to the 2x into x minus a half. Just means I've got to do a little bit of less algebra when I put the numbers in, rather a little less calculating. So now I put my limits in. So this is going to equal 3 over 2. So that's e to the, first putting the limit 3 in, so what's that going to be? e to the 2 times 3 is 6, brackets 3 minus a half, minus e to the 2 times 2 is 4, 2 minus a half. So I can tidy that up before I get my calculator out. So what's that going to be? 3 minus a half is 2.5. 2.5 e to the 6 minus 2 minus a half is 1.5 e to the 4. And now I get my calculator out and work out the answer. And I get 1,390 to 4 significant figures.